Today we're going to talk about x and y intercepts. In order to give this some context, let's look at an application problem to help us so we can visualize what this looks like. So you have $30 in your digital wallet. Each day you buy a fancy coffee drink that costs $5 with the tip. Write an equation that relates how many drinks are purchased with the balance of the digital wallet. So I want you to let x equal coffee drinks purchased and let y equal the balance of the digital wallet. And what I'd like you to do right now is to write an equation, and then I'd like you to choose some values for x, some input values that make sense in this context, and create a table of values that you can then graph. So what I'd like you to do right now is pause the video and go ahead and do all of those steps. So write your equation and then graph it. So let's see how your graph compares to mine. The equation can be written in two different ways. Y is equal to 30, that's how much you start with, and each coffee drink that you buy is $5 is deducted from your balance. Because of the commutative property, we can also write that equation. Y is equal to negative 5x plus 30. So we just remember that plus a negative here, addition is commutative, and so that works. So what I did was I created a table of values. I didn't use any negative numbers because in this case that doesn't make sense. So I started off with 0. When I plug in 0, negative 5 times 0 is 0 plus 30 gives us 30. When I substitute 1, negative 5 times 1 plus 30 gives us 25. When I plug in 2, 2 times negative 5 is negative 10. Negative 10 plus 30 is equal to 20, and so on. So you'll notice that as we move down the line here, it's going at a constant rate. Okay, there's a constant rate of change of negative 5. Okay, and then we have our graph. And so we want to make sure that we have a title. So let's call it Coffee Rules. Okay, and I have drinks on the x-axis. That's my independent variable because the balance depends on how many drinks I've purchased. So we have 30, 125, 220, and so on. So we have the ordered pair 0, 30. Notice that this is called the y-intercept. And you can think about this as in sports. If you're playing football and you intercept a pass, that means that the ball is coming along here and another player intercepts that. So that's the intercept. Is y-intercept. It's where the graph crosses the y-axis. Okay, and notice at that point the x is equal to 0. Likewise, with our x-intercept, we have the point 60, and notice that our y is equal to 0. So let's see how that works with this same situation. So what we're going to do is x and y intercepts work really, really well when an equation is in standard form. And the standard form of a linear equation is ax plus by is equal to c. And this formula, you can use this to help you determine if an equation is linear. If it can be written in this format, then we know that it's going to be a straight line. Another thing to remember about the standard form is that a, b, and c must be whole numbers. Okay, they can be integers, negative, and positive whole numbers. So what I'm going to do is I'm going to write our equation for our previous situation in standard form, and then let's see how we can calculate the x and the y intercepts. So in order to write this in standard form, I need my x term and my y term to be on the same side of the equation. So I'm simply going to add 5x to both sides. So I get 5x plus y is equal to 30. In order to find the x-intercept, recall that from the graph, our x-intercept is when y is equal to 0. So I am going to, I like to do this, it makes it really easy. I just cover up the y because y is 0, and then I solve the equation. So 5 times what number gives me 30? And so our x-coordinate is going to be 6, because 5 times 6 equals 30, and my y-coordinate is 0. If we're going to find the y-intercept, we're going to let x equal 0. So I can follow that same step again. I can simply cover up my x because 5 times 0 is equal to 0, and that leaves me with y is equal to 30. So the x is 0 and the y coordinate is 30. This is a really nice way to graph because we can simply so we have our y-intercept is 0, 30, and our x-intercept is 6, 0. And that's enough information for me to graph this line. So remember, when you're graphing, if an equation is in standard form, that might be, x and y intercepts might be a really, really good choice for graphing. And when in doubt, you can always make a table. So right now, I'd like you to answer these questions. What does the x-intercept of the coffee problem represent? What does the y-intercept of the coffee problem represent? The last thing you're going to do is on your paper, on the notes sheet that you have, you're going to go ahead and graph these 3 equations using the x and y intercepts.